Imagine you're taking an important exam. You reach a question that stops you cold. Three possible answers: A, B, and C. You're not completely sure, so you trust your instinct and choose A. You move on, but later, as you review the question, you realize option C is definitely not the right answer. You also start to realize both A and B can possibly be the correct answer, but you're not sure. So, should you stay with your first choice or switch? While it feels like a 50-50 toss-up, the reality is that switching actually doubles your odds of winning. So here's how. At the start, you clearly have a 1/3 chance of picking the right answer. Once option C is eliminated, you may think that the probabilities reset to a 1/2 split between the two remaining answers. However, that's not the case. To visualize why this is wrong, imagine a deck of 52 cards. If you pick one card at random, you have a 1 in 52 chance of holding the ace of spades. If someone then flips over 50 other cards that are not the ace, leaving only your card and this one facing down, which is more likely to be the winner? Your original random guess remains a 1 in 52 long shot, while the remaining unturned card now carries the other 51 in 52 of the probability. In the three-option scenario, the same logic applies because of how you arrived at the two remaining choices. There are only two real possibilities. Either you pick the right answer initially, a 1 in 3 chance, or you pick the wrong answer, a 2 in 3 chance. If you pick the right answer, staying wins. However, if you pick the wrong answer, which is twice as likely, then eliminating option C leaves out the only other incorrect answer. In the majority of cases, the right answer is guaranteed to be the only option left, meaning switching wins 2/3 of the time. This paradox, also known as the Monty Hall Problem, has famously perplexed scientists and mathematicians for decades because our intuition struggles to grasp how new information changes old odds. If we look at the data across all 9 possible outcomes of the game, the math is undeniable. Staying only results in a win 3 out of 9 times, while switching wins 6 out of 9 times. Despite what your gut tells you, the simulations and calculations don't lie. Next time you're in an exam, remember, the math says it's better to switch.